All right, here we are, page 4. Which transformation of triangle TRS creates triangle, TRS prime, basically? So to get from here to here, we're going to flip it over the y-axis. So that's a reflection over y-axis. And then once it's flipped over here, it's going to be about right here. You got to move down 3. So translate down 3 units. And there you go. Beehives is a regular hexagon. The diagonals from V are drawn. The question didn't come out when we copied it originally, but it simply should ask, what is the measure of the sum of the numbered angles? Basically, what is the measure of that? And angle V is a inscribed angle, and it should be half of the arc it intercepts. Now, if you follow V, it goes out to S, comes around BEHI, and it's a hexagon inside. So one way you could do this is do 360 divided by 6 gives you 60, meaning the degree between every 2 letters. Nope. The degree between every 2 letters is 60. And so that's 1, 2, 3, 4. So arc SEI is 240. The 4 numbered angles, basically angle V, is equal to 1/2 the arc it intercepts. So half of 240 is 120. What is the area of the isosceles trapezoid? Very easy, except don't forget this little red triangle here. This is one of the Pythagorean triples you all should know by now for a right triangle, 5, 12, 13. But if not, you do 13 squared minus 12 squared, which is 25, and square root it. As far as area of the trapezoid, 1/2. So now this extra 5 makes this 18, plus the base on top 8, times the height, which is 12. So 18 plus 8 is 26. Half of that is 13. And 13 times 12 is 156, I believe. That was not music okay, it was music that just played. Shouldn't lie, right? Like all the times you were like, sir, is this for a grade? And I was like, yeah, it's totally for a grade. And it always wasn't for a grade. But y'all tend to not do work if we don't grade things. So, yeah, I was right. 156. Find the area. I know there should probably be a few more things to detail, but this is a regular not a regular hexagon, I should say, regular heptagon, because there are 1, 2, 3, 4, 5, 6, 7 sides. Area for a regular polygon is 1/2 times A times P. 7 times 9 is 63. The apothem given to you there is 9.3. So I'm just going to put in the formula. 1/2 times 63 times 9.3, and that is 292.95. 29, what is the exact area in square centimeters of the outer shaded region? If they're asking for an exact area, you don't want to round a decimal. So what you're going to have to do is, like we did with pi earlier, or the same thing I should say we did earlier, where you don't multiply pi through. So we're going to find the area of the big circle, which, if this is 3 and that's 7, that's going to be 10. So for the big circle, we're doing pi times 10 squared, which obviously just leaves us at 100 pi. And for the small circle on the inside, we're going to do pi times 3 squared, which is 9 pi. So when you subtract that, the shaded region is going to be written as 91 pi. That would be the exact area. It wouldn't have been rounded off in any way. It's just written in a way that you can figure it out. So, 30, which arc has a measure of 250? Got to find some missing angles. We got vertical angles here, so that's 70. This is 110 because a straight line is going to be 180. So whether you use that 70 or this 70, that's going to make 180. And then 70 and 50 here is 120. That leaves that to be 60. So the question is, what actually adds up to 250? Well, it's going to be this, because 70, 70, 60, 50, 14, 20, 25. So a few ways you could write it: BAC or BEC. Really, any three letters where B and C are the outside letters, and then one of these three is in the middle. Multiple choice, you have to choose, obviously, but any of those will work. But that part of the circle, that major arc. 31, the circles P, R, and Q are showed below. The diameter of circle R is 22. So if the diameter is 22, the radius is 11. What is the length of PR? A lot of people mess up because they add that extra 5 in there. It's from P to R, right? From one point to the other, so you're only adding those four numbers. 5 plus 9 plus 9 plus 11. And so 18 plus 11 plus 5 is 34. A rectangle contains two inscribed semicircles, and a first full circle is shown below. Find the area of the non-shaded region. The idea here is to find the area of the big rectangle using the radius. That's 6 across, or 6 is the height. Going across, you have 3, 6, 3. That's 12. 12 times 6, 72. For the circles, you have two circles that have a radius of 3. So 2 times pi, radius of 3, yeah. So 2 times pi times 3 squared equals 56.548. 6, yeah, big number. Anyways, so 72 minus 56 point, we'll do 549. And the shaded region is about 15.451 or 15.5 if you want to round it off. 4 pages down, 3 to go. Will we make it? I don't know.